So in this next video regarding binomial expansion, I'm going to show you how we can expand a plus bx to the power of n when n is a positive integer and find the coefficient of x r in a plus bx plus n. So in my previous video, the constant was always 1 that was inside the bracket, and in this video I'm going to show you what we need to do when the constant is not 1 plus bx in our bracket. So in this particular video I'm going to be going through how we deal with binomial expansion when the constant inside your bracket is not equal to 1. Now I'll be going through vaguely similar questions to what we did in the last video, but manipulating that particular methods to work with this particular question. Now I'm going to show you two methods. The first method is going to be very linked to how we do binomial expansion when you've got non-positive integer powers. However, the second method kind of only really works for positive powers. And again, I would say the second method a lot of students tend to find a lot easier. However, it's still good to have an understanding about how both these two things work. So, getting started. So as you can see, we have been asked to expand 2 plus x to the power of 4. And we note that here our constant is not equal to 1. Now also what I've got is Pascal's triangle, and again if I wanted to work out each of these coefficients I could either use the formula or I could just quickly draw a triangle. So back to this particular question. What now? Again, when we looked at the previous examples and Pascal's triangle and the formula that's in your formula book, which was 1 plus x to the power of n equals 1 plus nx plus n minus 1 over 2 factorial x squared and so on, that this only applies when you've got a 1 when our constant inside the bracket is positive 1. So what we need to do first, our first step, is to factorize to make the constant equal to 1. So what I need to do is factorize this particular bracket, making sure that I've got 1 there. So what I'm going to do is I'm going to divide everything inside the bracket by 2. So if I get a different colour pen so you can see what I'm doing. So from this I'm going to have 2, and then in my bracket I'm going to have 1 plus, now x divided by 2 is x over 2 or half x depending on how you prefer, and I've got a 4. Now, as you can see, the power of 4 is connected to the bracket, and I can't simply factorize in this way because the bracket's kind of protected by that power. Now, if I was going to do this, then what I also need to remember to do is that as that bracket has got a power, I also need to take the factor to the power of 4 as well. So 2 to the power of 4 is 16. So what this then becomes is 16 1 plus x over 2 to the power of 4. And again, what I'm going to do is just to make a little note on that. So make sure you raise the factor by the power. So as you can see, I've taken the 2 and I've raised it to the power of 4 because the bracket outside the bracket is 4. So going on to our next stage, once I've done that, the next thing I then need to do is now expand the bracket using Pascal's triangle and the previous method. So what I'm going to do for starters is I'm going to ignore the 16 for now, in which I've got 16, and I'm going to open up a square set of brackets. Now because I'm dealing with the power of 4, I need to be looking for the 5th row of Pascal's triangle, which is just there. And what I'm going to do is first note those coefficients first, in which let's use orange. So I've got 1 4 6 4 and 1, and let's put a close bracket there. And what I then need to do is add my x to the power of 2 there. So I've got 1 plus, and then I'm going to have x over 2, then x over 2 squared, x over 2 cubed, and then x over 2 to the power of 4. And I am adding each of those up. I don't know why I put another plus there, so let's get rid of that. So from this, what I then need to do is get a bit more space. And now what I'm going to do is simplify the square bracket. So my next step is to simplify the square brackets. Now, if you're not too sure about what I've done with step 2, then I recommend you watch my previous video on binomial expansion. So moving on from this, what we've got is these difficult, let's go for it, let's keep it consistent. So from this, what I've got is I've still got the 16, which I'm just going to ignore for now. And what I'm going to do is simplify this square bracket out. So to start off with, I've got 1 plus, and it's going to be 4 over 2x plus 6 over 4x squared. And again, because remember, I've got to do x squared. So when I'm squaring this, I need to square both the numerator and the denominator, so that becomes x squared over 4, and times that by 6 becomes 6 over 4, plus 4 over 8x cubed, plus 1 over 16x to the power of 4. And then what I then need to do is, once I've done that, now at this stage I could either simplify each of these. So what I could do is go on to write this as 1 plus 2x plus 3 over 2x squared plus a half x cubed plus a 16th x to the power of 4. And then all I then need to do is my final stage is then multiply out the original factor. So all I'm now going to do is multiply everything that's inside the square bracket by everything that's by 16. So what I've got is I'm going to end up with 16 plus 32x plus 48 over 2x squared plus 16 over 2x cubed plus 16 over 16x to the power 4, which, if I then simplify each of these, and again I'm just writing out exactly what I've seen rather than simplify it further. However, I could have easily jumped to the stage depending on how comfortable you are with your multiplying and dividing. So here I've got 16 plus 32x plus 24x squared plus 8x cubed plus x to the power of 4, and there is my expansion. Now what I'm going to do is show you another way of answering these types of questions. Now, looking at our final answer, what you've got to appreciate is that in your expansion, each term is going to consist of 3 parts. Now the first part is what we're going to call Pascal's coefficient. Then we've got the first term, which in this case is 2. And then we've got our second term, which is going to be our bx. If I just label this at the top A, and we call this bx, and this is our nr using our calculator. Now in this particular question, our first terms, if I get a different colour pen, let's go for green. So in this particular version here, we've got our Pascal's coefficient is just going to be from Pascal's number, from his triangle. Our first term in this case is 2, and our second term is single x. Now obviously if this was 2x, then it would be 2x. If it was, let's say, minus 3x, then it would be a minus 3x, and likewise if the 2 was of a different sign, then that would be the same as well. So looking at Pascal's coefficient first, so here what we've got to do is find, so our first value. Now because n is going to be 4, I want the coefficient when x is 0. Then I want x1, then x squared, x cubed, and then finally x to the power of 4. And if I either from the triangle or from our calculator, if I enter these in, and again, if you're not sure how to enter this on the calculator, just use the NCR function. And if you're not sure, have a look at the previous video which it goes through. We've got 1, 4, 6, 4, 1. Now in terms of the first term, now in this case my first term is 2, and if I just label that, so this is my first term. Now the first term, this, starts high and ends low. And so from this, now our highest power is going to be 4, so what I'm going to do is I'm going to have 2 to the power of 4, 2 to the power of 3, 2 to the power of 2, 2 to the power of 1, and 2 to the power of 0. And if you're wanting to, you can actually write down what those values are, like so. Now the second term that we've got here, which in this case is just single x, we've got, so if I get, where's that? Hang on, there it is. So this second term, this starts low and ends high. So from this, what I've got is I've got x to the 0, x1, x2, x3, x4. And obviously this does not require any further simplification, so that's basically what it is, and apart from that one just being 1. Now from this, what I then need to do is to multiply for each row. So each term is going to consist of the multiplication of each of the numbers or the values of x in each row. So what I mean by that is, if I get a different colour pen, so what I'm going to do is I'm going to multiply each of those highlighted yellow cells in each row together. And what I end up with is, so 1 times 6, so 1 times 16 times 1 is 16. 4 times 8 times x is 32x. 6 times 4 times x squared is 24x squared. 4 times 2 times x cubed is 8x cubed. And 1 times 1 times x to the power 4 is just 4x to the power 4. And what I then now need to do is just simply add, oh, wrong choice of colour there, is add each of these 5 terms together. So what your final answer will look like, if I just scroll up or down, I should say, a little bit, so I've got a bit more space. So your final answer will be where you are adding each of those things together. So it will be 16 plus 32x plus 24x squared plus 8x cubed plus x to the power 4, which you can see that that gives us the exact same answer as doing it in the previous method. Now obviously you can choose which method you prefer. With a bit of practice, one will always work. I tend to find, going on my own personal opinion, the second method is probably a lot quicker, and also by setting your work out a little bit neater, it makes it easier for you to spot where there is a mistake. One thing that a sort of disadvantage of using this method is that it doesn't really work going forward into year 13. Although the structure for method 1 kind of helps understand what the next stage will look like, and it's not the final product, it's a case of what's going to stop you from making any silly mistakes and also maximising your marks when you're doing this in an exam. So in this next example, I'm going to show you a different type of question that's also commonly asked in exams and in textbooks. Now in this particular question, we're asked to expand 2 minus 3x to the power of 6 up to including x cubed. Now in this particular question, they're not expecting us to expand the function out completely. It's just asking us to go to a certain point. Now, what I'm going to show you, what I'm going to go through now, is I'm going to show you the second method of how we do this, because like I said, with a bit of practice and with a bit of time, it does prove to be a lot quicker, and again, easier for you to spot a mistake if you have made one. So going on from this, in terms of working through this, so here we've got, so again, working with the expansion, I've got Pascal's, because each term is going to consist of 3 parts. I've got the first term and I've got the second term. And what I'm going to do is, now I only need to go up to x cubed, so I only need to do the first 4 lines. So here I'm going to start off with 6, 0, then 6, 1, 6, 2, and 6, 3. And if I enter those numbers on my calculator, or I could instantly use Pascal's triangle, I get the values of 1, and then for the second one I get 6, NCR 1 I get 6, 6 NCR 2 I get 15, and 6 NCR 3 I get 20. Then for the second term, so the second term in this case is 2. Now remembering that 2 starts high, so it's going to be 2 to the power of 6, 2 to the power of 5, 2 to the power of 4, 2 to the power of 3. And the second term, now the second term starts low, ends high. Now the second term, you just need to be careful, because the actual second term is minus 3x. So it'll be minus 3x to the power of 0, minus 3x to the power of 1, minus 3x to the power of 2, minus 3x to the power of 3. Now from this, what I could do is either enter all of those components, ignoring the x's, into my calculator, and it will tell me what each term is, or if I had the time, I would work out the values of each of these. So for example, and probably what I should do is left a bit of space there. So what I mean by that is I would, if I had time, or if you got time at the end of your exam, is actually write down the values of what these are. So 2 to the power of 6 is 64. That's 32, that's 16, and that's 8. This is going to be 1, that's going to be minus 3x, this is going to be positive 9x squared, and that's going to be minus 27x cubed. So what I'm now going to do is multiply out each of those 3 things. So if I get a difficult pen, what I'm going to do is I'm going to multiply each of these 3 things together. So I'm going to multiply 1 times 64 times 1 plus 6 times 32 times minus 3, 15 times 16 times 9, 20 times 8 times minus 27. So going back to this and using my calculator, I'm going to work out what the value to each of these 4 things are. So I've got 1 times 64 times 1 is going to be 64. 6 times 32 times minus 3 is minus 557x. 15 times 16 times 9 is 2160x squared. And 20 times 8 times minus 27 is going to be minus 4320x cubed. Give you my final answer as 64 minus 576x plus 2160x squared minus 4320x cubed. Now, one thing you do need to bear in mind with these particular questions is sometimes having numbers dealing with big numbers like minus 576 or 2160 or minus 4320, you might give you the impression that I've done something wrong. Now in these particular questions you could end up with a coefficient that's in the tens of thousands, or even I've even seen a question where it's gone into 100,000s. So don't be nervous when you're dealing with big numbers, or if you find that you've got large or ridiculously small, thinking in negative terms, your coefficients of x, because that's completely and utterly feasible, and it's just a case of you and the examiner making sure that you are aware of what it is you're actually doing. Now what I'm going to go through is another typical question that you could get asked relating to this topic at this particular level, and that is by being asked to find the coefficient of a particular degree of x in an expansion. Now one way of doing this is to perform the full expansion and then finding out the particular requested degree of x, or the coefficient of that. However, that's a lot of unnecessary work, and a much quicker way of doing that is by deriving this formula. Now you could either memorize this formula or just remember, or with bit practice of binomial expansion, you will understand where this all works. So just to get started, so I'm going to show you how to use this formula to answer this particular question. So if I start off with a common question, which is if it's appeared by magic, we've been asked to find the coefficient of x to the power 8 in the expansion of 3 minus 4x to the power of 11. Now obviously doing that in the more traditional methods of doing the full expansion is going to be very time consuming. So what I'm going to do is I'm going to show you how we can use the above formula to work this out. So starting off with getting a decent colour pen, and again let's go for purple. So from this what I'm going to do is, now in this particular question my n is 11, the r value, which is the requested power of x, or the degree of x I'm wanting, which is 8. My a in this term is 3, and my bx in this particular case is minus 4x. So what I'm going to do is I'm going to substitute these four things into this highlighted formula. So the coefficient of x to the power of 8 is going to equal 11, 8 using the NCR function on the calculator, times, now I'm going to use brackets in this just to make it easier, you can see what I'm doing. So here it's 3, and then I've got n minus r, which is going to be 3, and again if you're not sure where that's come from, it's 11 take away 8, times my bx, which in this case is minus 4x, and again I've purposely picked quite awkward numbers and a negative number in this so you can show how it's used in this particular formula. So again, remembering I've got minus 4x, not just 4x, and that's going to be to the power of 8. So all I then need to do is enter this in my calculator and simplify where possible. So here I've got 11 NCR 8, which is 165, times 3 cubed, which is 27, times minus 4 to the power of, just bear with me, minus 4 to the power of 8, which is 65536x to the power of 8. And if I simplify all of that together, I get 165 times 27 times 65536 equals 291962880x to the power of 8. Now, as I said in the previous video, that when you're asked to find a particular coefficient, we're not expecting this. They're trying to get away from writing what we're actually trying to find. The actual answer to this particular question is this number here. So the final answer you should write is 291962880, and there is your final answer. So as you can see, using this particular method is a lot easier than doing the expansion out fully. So what we do now is just go through some extension style questions once you are happy with what we've done so far. So in this particular question we've been asked to expand 2 plus x multiplied by 1 plus x to the power of 5. Now as you can probably appreciate is that this part here is our binomial expansion. So what we first need to do is to expand that out first. So as it's 1 plus x, that what we can do here is recognize that 1 plus x to the power of 5, and using Pascal's triangle, is going to be equal to 1 plus 5x plus 10x squared plus 10x to the power of 3 plus 5x to the power of 4 plus x to the power of 5. So when I'm then going to multiply out 2 plus x to the power of 1 plus x to the power of 5, then that's going to be equal to 2 plus x times all of that above expansion out. So it'd be 10x squared plus 10x cubed plus 5x to the power of 4 plus x to the power of 5. And what I'm going to do now is just simply multiply out, as I would do normally, we're using the loops, and go from there, which should give you the final answer of 2 plus 11x plus 25x squared plus 30x cubed plus 20x to the power of 4 plus 7x to the power of 5 plus x to the power of 6. And as you can see, by multiplying this way, we can see that we've got our ascending powers of x, leaving us with this as our final answer. So in this second example, we have been asked to expand 3 plus x multiplied by 1 plus x to the power of 6 up to and including x squared. Now it's really important that we read the question carefully and note that this is just asking us to only go up to x to the power of 2. So for this, I'm not expanded to completely and utterly expand the whole full equation out, which may be very time consuming. It's only asking me to go to a certain point. Now, using a bit of common sense with regards to this, when I'm doing the expansion of 1 plus x to the power of 6, now because eventually I'm going to be multiplying this by 3 plus x, that I only need to really go up to x cubed, because that's going to be the highest power of x, because any other degree of x is going to be unnecessary for this particular question. So expanding this out, as I said, I only need to go up to x power to the height, well, 1 extra from this. So here I've got 1 plus 6x plus 15x squared, and just to play it safe, although it's not really necessary, I'll go for 1 extra, which is 20x cubed. So from this, and going back to the original question, I've got 3 plus x, 1 plus x to the power of 6 is going to be equal to 3 plus x multiplied by 1 plus 6x plus 15x squared plus 20x cubed. Now, as I've said, there isn't really need for me to go up to 20x cubed. However, the highest power of x I need to go in the binomial expansion commonly is going to be x squared. However, that might not be always the case, so it's always worth just going a little bit extra. So from this, what I now need to do is to expand this out, and if I expand this out, I get 3, so multiply everything in the second bracket by 3, so I get 3 plus 18x plus 45x squared plus 60x cubed, and then I'm going to multiply everything in the second bracket by x, in which I get 1x plus 6x squared plus 15x cubed plus 20x to the power of 4. And then all I then need to do is just simply add those two expressions together. So I get 3 plus 19x plus 51x squared plus 75x cubed plus 20x to the power of 4. Now, because the question is only asking me to go up to x squared, if I included this, I would lose marks. So what I need to do is get rid of those two things there, and my final answer is going to be 3 plus 19x plus 51x squared. So in this third example, we've got a very similar question to number 2. So again, looking at this, we can see that we've been asked to expand 7 minus 2x, 3 minus x to the power of 4, up to and including x squared. Now, for this, what we need to do is first expand 3 minus x to the power of 4, going only up to x squared. So I don't need to do the full expansion, I only need to go up to x squared. So here if I've got 3 minus x to the power of 4, and that's going to equal, and now doing the expansion, so here we've got 4, 0. So again, using the method of using the 3 columns, then I've got my first number, which is 3, and that starts high, and the second term, which is minus x, and that starts low. So that's my first term, and that's going to give me my constant. The next one is going to give me 4, 1, which is Pascal's number. Then this first term, lowering the power by 1, and then I've got minus x to the power of 1, plus 4, 2, and then 3 squared, and then minus x squared. So simplifying each of those things out, I get 81 plus, or should I say minus 108x plus 54x squared. And what I've done here at the top here is I have just, rather than drawing columns, I've done the exact same process and just gone from there. So here I can see that my expansion of 3 minus x to the power of 4, of its first up to x squared, is going to be 81 minus 108x plus 54x squared. So returning back to the question, I've got 7 minus 2x, 3 minus x to the power of 4 is going to be equal to 7 minus 2x, and then I'm going to have 81 minus 108x plus 54x squared. And again, I only need to go that far because I'm only interested in going up to x squared. Now, expanding those brackets out, I get 567 minus 756x plus 216x squared minus 216x cubed plus 108x to the power of 4. Now, as I said that in the original question, it only asked me to go up to x squared, so I don't need these last two terms, so my final answer is going to be 567 minus 556x plus 216x squared. And again, if I was to include those two terms, I would lose marks in terms of presentation of my final answer. Now, in this final example, I've purposely picked quite an evil looking question. So in this particular question, we've got to expand 3x minus 2 over x to the power of 4 and state the coefficient of x squared. Now, it's quite rare for you to see an expansion like the bracket, the function that we've got here, where we've got two values of x, but there is quite common. First term could be anything, so it could involve any letter, so it could be x's, could be y's, it could be multiple letters, it doesn't make a difference. But the key thing to remember is that you've always got two terms inside this bracket. So in this particular case, my a is going to be 3x and my bx is going to be minus 2 over x. And our power is 4. So in this particular example, so it's worth making a note of that. So in this, what we've got is we've got a equals 3x. Our bx is equal to minus 2 over x, and our n is 4. So using this, what I'm now going to do is substitute this into my expansion. Now again, as it's quite complex, I would go for the option of using the 3 columns, but what I'm going to do here is just show you a much shorter way of doing this. Now, in terms of presentation wise, I'd probably go for the column method. However, to make my life a little bit easier when explaining this, I'm going to do each of the columns in single terms. So what I mean by that is, so looking at the expansion, so the first thing I'm going to have is 4, 0, so that's Pascal's number. Now my first term, which is 3x, now this starts high, so that's going to be to the power of 4, and my second term starts low, so that's going to be minus 2 over x to the power of 0. Now working all of that out, I get 1 times 81x to the power of 4, and anything to the power of 0 is 1, which leaves me with 81x to the power of 4. So that's my first term in the expansion. Now the second one, I've got the second of Pascal's number, which is 4, 1, or the NCR, 4 NCR 1. Then at the first term, moves down one, so that becomes a cubed, and minus 2 over x then starts increasing its powers. So multiplying this out, I get 4 times 27x cubed multiplied by minus 2 over x. Now 4 times 27, if I just grab my calculator, 4 times 27 equals 108, times minus 2 gives me minus 216 x cubed over x. And if we simplify that, that gives me 216 x squared, because the x's will cancel out. And lo and behold, I found my coefficient of x squared. So for the third term, I've got 4, 2, 3x to the power of 2 minus 2 over x squared. So 4 NCR 2 gives me 6 times 9x squared times, now minus 2 squared is going to give me positive 4 over x squared. So that then leaves me with 6 times 9 times 4, which is 216 x squared over x squared. So let me just double check that, yeah. And so that will then leave me with just 216 because the x squareds cancel. So moving on to the next one, we've got 4, 3 x cubed. So 3x going to lower the power by 1, so that becomes to the power of 1. And then minus 2 over x, and that increases by 1. Now, one thing to note is remember that I'm including the minus 2 inside my bracket, because obviously with negative x's, you don't want to lose that negative, because obviously that's where it starts going a little bit more pear-shaped. So moving on from this, we've got 4. So 4 NCR 3 gives me 4 times 3x times minus 8 over x cubed, which then gives me 4 times 3 times 8, which gives me 96. So that's going to be 96x over x cubed, in which then the x's then cancel, leave me with 96 over x squared. And then finally, for the last expansion there I've got, so I'll just move that up a little bit. So here I've got my Pascal's last number, which is 4, 4, 3x to the power of 0, minus 2 over x to the power of 4, which then leaves me with 1 times 1 times 16 over x to the power of 4, make that look like a 4, which then just gives me 16 over x to the power of 4. Now, one thing to note is that sometimes they like you to write your answers using indices. So if you're not sure about what I mean by writing with indices, check out my video on that. So how I can write this is this can also be written as 96x to the minus 2, and this could be written as let's get rid of that, and this could be written as 16x to the power of minus 4. So how I'd end up with my final answer is by adding each of those things together. So for example, adding 81x to the power of 4 minus 216x squared plus 216, 96 over x squared, and 16 over x to the power of 4, which leaves me with a final answer. So my final answer to that expansion is going to be 81x to the power of 4 minus 216x squared plus 216 plus 96x to the power of minus 2 plus 16x to the power of minus 4. Now, one thing I would suggest that you do, and obviously the last part of that question, is that the coefficient of x squared is going to be minus 216, not to minus 216x squared, remember. Now again, with these particular questions, just be extra careful when you have got divisors of x inside your function. So what I mean by that is, if I just return up to the original question, so here And what I mean is this bit here. So when you have got a negative when you've got a fraction involving x as the denominator, just take extra care when you are doing the expansions, because as you can see, when we did the expansions, a lot of the x's were cancelling out, and that's something to be wary of. So try not to take these questions at face value, particularly with these more high level questions, because like I said, sometimes they sometimes catch you out when you fail to recognize what they actually mean. So that completes the tutorial of binomial expansion for this level. I hope it makes sense. If you're requiring any additional worksheets, then please do drop me an email at 162maths@gmail.com.